everyone, and welcome to today's webinar, Accelerate the Adoption of You Build It, You Own It with Self-Service Operations, sponsored by Rundeck by PagerDuty. I'm Jenna Sargent, News Editor of SD Times. Now moving on to the topic of today's webinar. Within the context of incident response, teams need the ability to clearly define who is responsible for attending to issues, how they're notified, and who to lean on for help. One of the keys to allowing for service ownership outside of incident response is by imbuing an organization with a culture of self-service operations. That means a service owner builds and delegates self-service mechanisms for end users to make use of a given service safer while also reducing the number of interruptions to the service owner. In this webinar, Jake Cohen, Senior Solutions Consultant at PagerDuty, will explain the benefits of this ownership model and how to implement it within your organization. Now to get things started, I'll turn it over to you, Jake.
Thanks, Jenna. Hey, everyone. Nice to meet you all. I'm Jake Cohen, Solutions Consultant for the Rundeck team here at PagerDuty. And in today's session, we're going to look at how Rundeck and PagerDuty can enable teams to adopt various service ownership models and hopefully get on a path to full service ownership if that's your intended goal. So we're going to dig right in, and to kick things off, we're going to look at what we mean by this model of you build it, you run it. Service ownership is an operating model where typically the developer or developers of a given service are empowered to own their code and services at every stage of the development lifecycle. There's many reasons to move to an operating model like this. It empowers engineers to own the systems they create, leading to higher software quality and more resilient systems. It increases collaboration between teams and puts the focus on real-time operations. So we'll put all of this into practical terms and look at some specific examples around what it means to own a service and what the varying types of service ownership operating models look like in practice. What is included in owning a service? And there's probably no truly exhaustive list, but there are a few areas to focus on. The first is in the actual feature development stage. Developers are working closely with product managers to better understand the end goal of the user experience. And they're more involved in infrastructure architecture discussions, so working more closely with platform engineering. With CI/CD practices now commonplace, they are not only involved, but responsible for defining and maintaining the processes around integration and deployment. Perhaps the most frequent sign that an org has moved to a full service ownership model is that their developers are now responsible for responding to incidents. Maybe they're part of an on-call team or rotation, and they receive alerts pertaining to their specific service. There are many other aspects of what it means to own a service, such as responding to requests by business users about a service, but this provides a good sense of a wide array of responsibilities that fall on service owners. And one thing to keep in mind too is when we talk about a service, this could mean a component of your production customer-facing application, but it could also mean an internal service, right? Something that's used to keep operations and the business moving day to day, right? So this could be a data pipeline service, maybe to extract customer information or customer data from your production application and provide it to a BI tool that you use internally for analytics or for developing new features. And so your service is it's a more generic term, and keep that in mind as we go through the discussion. So along those lines, right, there isn't a one size fits all, and you can think of it as a journey, right? If your end goal is full service ownership. And so the responsibilities on service owners will vary because of this, depending on the operating model you've moved to or where you are in that journey. So for example, as you can see here on the right, developers might be in an on-call rotation to respond to incidents across their multiple services, or maybe you have a whole product area and there's a rotation of developers or service owners within that product area. But again, they each know their specific service more than another service in that product area. You might have in the middle here, operations engineers might be serve as like a first responder layer, but then escalate to the service owner when the issue is much deeper in the application layer than they are familiar with. Or you might be closer to that full service ownership where all high priority incidents immediately page the service owners for their specific service. And there are likely other incident response operating models that you've seen or have already implemented. But at the end of the day, what's clear is that service owners have become far more involved with the production operations of their services, and they're responsible for far more than just developing and maintaining code. So without a doubt, one of the key ingredients here to moving to an operating model of service ownership is paging the right people at the right time and with the right information when incidents occur. And for those familiar with PagerDuty, this is where PagerDuty fits in to this equation and excels. You're able to send all of the data signals from your infrastructure layer and your application layer to PagerDuty, and then notify the correct individuals such that you can resolve incidents as quickly as possible. And this is always an evolving configuration because you're constantly adding new features, new team members are coming on board, and you're always trying to improve the software development and operations processes. Regardless, though, of kind of where you are in these operating models, right? There's always the patterns of incident response that are very hard to get away from, which is that tickets and alerts still escalate. Whether that's to the service owner or to the subject matter expert for a given piece of the architecture or infrastructure. And this could be because the issue is maybe it's too deep in the application layer for someone on the operations team to respond. Could be that maybe the service owner for this service has built in certain mechanisms for responding to that type of incident. Maybe the first responder attempted to resolve the issue on their own, but wasn't able to. And so because the service owner didn't provide others with documentation on how to resolve certain issues, they've had to escalate it. And going back to the generic, more amorphous term of a service, incidents are just part of service ownership, right? Think about the incidents are just one form of interruption that a service owner might get in terms of owning their service. They're frequently interrupted from their strategic project-based work for things like environment management, capacity planning, reporting, performance tuning, right? Maybe if you're responsible for if you have an e-commerce app, you're responsible for the shopping cart service, you're going to get questions around how frequently are people using this service in this way? What is the data telling us about this service, or what is the forecasted infrastructure requirements for this service? And the end goal here is really to reduce these interruptions as much as possible. And as you can see here, right, incidents are just a slice of the pie in terms of what service ownership truly entails. So this is where we start to talk about automation and runbook automation specifically, meaning service owners, whether that's developers or again site reliability engineers building internal services. There's no shortage of automation that these people can build and rely on to automate these tasks that we just saw on the previous page, such as reporting and capacity planning and configuration management and deployment, etc. But what we often find is that the tooling that is used by one group to help them manage their own service is not as easily accessible to others outside of their specific team or their specific service owner group. And this might be because one group just isn't familiar with certain tooling or certain automation. Maybe one group doesn't have the necessary access. So if we're talking about we want to give developers full service ownership, but they are, at least today, by company policy, not allowed to take certain actions in production because of, again, security and compliance reasons, or we just don't have a good mechanism to allow for that today. And so you see what we call the automation gap, which is that in a journey to full service ownership, there are typically barriers to getting there, even though the automation may already exist for getting around these tasks and auto remediation if we're talking in the context of incidents. So this is where runbook automation comes in. Whether you're a developer or an operations engineer, the purpose of runbook automation is to equip others or even your own team with expertise such that they can help you support and maintain your service. So as shown here, a service owner can author these workflows related to whether it's deployment or maintaining and remediating their service into Rundeck. And Rundeck is our runbook automation tool. So these workflows can include any type of programmatic or automation protocol or tool. They can also include our out-of-the-box integrations with common infrastructure tooling and application tooling. So a single automated workflow might include steps that include Terraform, the AWS CLI that you see here, shell commands on remote nodes, Ansible playbooks, Bash scripts, Python scripts, and so on. Really anything and everything that you might use today to manage and maintain your services and infrastructure. And these workflows can then be invoked by users through the simple GUI, the Rundeck web portal, through API or CLI, or from webhooks from tools that you and your org live in every day, such as PagerDuty, Jira, ServiceNow, and Slack. So what this does is it ultimately distributes the service owner's expertise with other people across the development and operations teams. And even outside of those teams, you might think of your customer support team or internal IT teams. And this equips others with mechanisms to help that service owner support and deliver their service to their external and internal customers. So as depicted on the right side here, our service owner is able to focus on that more strategic work because others are able to get what they need without needing to assign or escalate tickets to the service owner. And so what we'll do is we'll take a quick example to put all of this into practice and show how a service owner that's very familiar with a very specific service is able to equip others to help them deliver their service. So what I'll do here is show that we have an e-commerce app. Some of you may have seen this demo app from our partners over in Chaos Engineering. And I have items on my store that I can add to my cart. I can see other recommended products and browse these and add them to my cart, and then I can place an order. And this web app here is hosted on Kubernetes. It's a microservice, about a dozen or so services. And what's more interesting, though, is overlaying what might be the service owners of these particular services. So we can see Alice develops and owns the ad service, Carl for the cart service, so on and so forth. So this team might have an operating model where they might be in an on-call rotation across the service owners, or there's an operations team that serves the first responders, but then pull in service owners as needed. Again, it all depends on where you are in this journey for full service ownership, or where you ultimately land as being most optimal for you and your teams. But in either case, it's fairly common for people to be on call and paged about services for which they are not the service owner and therefore not the most knowledgeable person. And it is for this reason that many incidents are escalated to service owners because they are the most familiar with the underlying code. So we'll look at an example here where, say, Rachel, who owns the recommendation service, is the first responder when an incident occurs with the checkout service, and where that issue is dependent on a service she's not super familiar with, which would be Paul's payment service, which depends on these third-party APIs. And so what we'll do is look at what happens when one of these third-party APIs for the payment service goes offline or suffers some service degradation. So what we'll do is mimic that third-party API going down, and we're actually going to do that using API Gateway here. So here's our third-party API, and we'll go ahead and hit Edit, and we're just going to disable this here. And then what we'll do is we'll show how we can navigate our e-commerce app and place an order. And what you can see already is that we've received an error, right? So as soon as we try to place our order, there's an error, and this is, as we were saying, related to either the checkout service or the payment service or maybe even the cart service. We don't really know yet. What is interesting though, right, is that because of this architecture, the rest of the e-commerce platform is still working. It's really just this ability to place an order that throws an error. And so just kind of reviewing kind of where we're at, this is going to mean that Rachel in this situation gets the page that something is up with people trying to check out from their e-commerce app. And so we'll go into PagerDuty and see if our handy new relic has already triggered our incident. So we've got our first incident here. So this is what Rachel would be ultimately paged about first. And we can see here that New Relic has provided information about what has triggered this incident. It happens to be a synthetic check, and so we can see that it's a synthetic check from our Columbus, Ohio location, and we've got links to the incident in New Relic. This is all fairly generic information, right? This is what the monitoring tool knows is wrong, and most monitoring tools will they'll be threshold-based alerts or anomaly detection-based alerts, but ultimately they're going to provide you what they know about the alert at hand. What you probably have noticed though is on the notes here, and if we go to the timeline, there's already something posted as soon as this incident was created. And this is where the runbook automation comes into play. So as soon as this incident was triggered, this kicked off an automated runbook to go and fetch what we would consider diagnostic data related to this alert, to this incident. And as you can see here, these are recent pod logs. So this is logs related to the checkout service pod. And it's trying to replicate whatever that responder or service owner would do when an incident like this occurs. So if we think about the checkout service owner, what would they do when they receive an incident? They would go look at the pod logs. They would maybe go look at the actual pod status and what is Kubernetes saying about this pod, and maybe look at other related or dependent services, related pods that this particular service depends on. And so already this is trying to help whoever is on call better ascertain what the root cause is, or better escalate to the right people. So this was kicked off automatically, but what we can also show is that maybe there's some even more better deep dive diagnostic data that can be pulled as well. And that's what we see here is using PagerDuty's custom incident actions, we can grab even more diagnostic data from all of the service that the checkout service depends on. And you might be asking, well, why wouldn't we just kick this off automatically? We certainly can. This is to demonstrate that you might have certain actions that you take in responding to a service that isn't necessarily remediating the service yet, but it's a more invasive way of testing the environment. So you might want to send some data through a pipeline or mimic an end user action, make an API call that actually is a stateful API call, like trying to add a record or delete a record and see if that works. And you only want to do that from the touch of a button by a human. So that's what we're going to demonstrate here. So Rachel's on call and she sees the information here in the logs. This isn't super helpful yet, so she goes and clicks on the dependence diagnostic, and we can see that this has triggered a custom incident action. And when we go back to the timeline, we do see again that a note was added by Rundeck. And in a second, I'll show you what's going on behind the scenes in Rundeck. But just to kind of close up this segment here, what we do see is that this step has actually helped the on-call, in this case, hypothetical Rachel, determine that it's not really an issue with the checkout service that per se that's caused this incident. It's one of the services that the checkout service depends on. In this case, it's the payment service, and we can see that the payment service container has terminated with an exit code of 139. And so, again, maybe Rachel does or does not know what to do with that information, but at least now she knows where to start debugging and investigating, or who to escalate to if there's someone else that she can and should escalate to. So really quickly taking a pause here, what I'll show is what is Rundeck doing for this particular type of job. So in Rundeck, you have your repository of automated runbooks, right? Runbooks are, classically speaking, just a series of steps for a human to take for a given task, a series of instructions. Well, Rundeck is just a series of steps for an automation and orchestration platform to take. As you can see here, our steps are very straightforward, very simplistic, just to demonstrate the concept. But what we're doing, again, is just emulating or replicating what a human would do in this scenario, which is go in fetching the real-time service status of these pods, in this case, the payment service, the shipping service, and the email service, collating all of that information and posting it to PagerDuty. And as mentioned earlier, as you can see here, these Rundeck jobs are comprised of steps that wrap around existing automation or programmatic mechanisms that you might use, such as commands at the command line. But they also might rely on our out-of-the-box native integrations with tools such as PagerDuty, such as Jira, AWS, Docker, etc., so on and so forth. And we'll come back to this in a second, but let's kind of follow the story here where this takes our responder. So in this case now, our responder, Rachel, knows that the issue is related to the payment service. And as a matter of fact, if I refresh the page here, we do see now that there's actually a related incident. If I go ahead and hit refresh, we'll see that integer change to a 1. And so even with the dependence diagnostic, we were able to hone in on the fact that this was related to the payment service. And now PagerDuty has received another incident from New Relic, and it is related to the payment service pod. And so that's just helping validate for our responder where the issue is actually coming from. So we'll go ahead and dive into that incident, the payment service, because we're now fairly certain that this is where the incident is coming from. And same thing again, we do see that the pod logs have been automatically posted here by Rundeck. This time we actually do see a failure or error message in the log. So again, just helping further validate where the true issue is. But now the question is, what can Rachel, who's the service owner for the recommendation service, do about it? Right? She is part of the the e-commerce platform team, and so she's very familiar with a lot of these inter and intra dependencies, but she wasn't a developer for the payment service. She may or may not know that the payment service has some dependencies on these third-party APIs. But even if she did, does she really know what to do to safely restart the payment service or to decouple those dependencies? Probably not. That's where she would, in most scenarios, want to escalate to someone like Paul, who is the owner for that particular service. But this is where things can really evolve. With a tool like Rundeck, we're able to extract Paul's expertise and service owner level of knowledge for his service and encapsulate it in these automated runbooks and then make it available to someone like our on-call and be able to invoke it at the push of a button. So we can see here that the runbook is labeled no third-party APIs. It's to redeploy this service without the third-party API dependency. And there may be documentation either in Rundeck or in the wiki on when to use this type of runbook. And as you can see here, we could add multiple runbooks to a given service. And so there might be instructions on, if the error message is such and the behavior is this, then go ahead and click this button for that runbook. And so it's really trying to not make any assumptions about the end user's knowledge of this service. So we'll go ahead and invoke that, and similar to last time, we'll see that the custom incident action was activated by myself. In our scenario, or in our hypothetical, this would be Rachel for the recommendation service owner. And when we refresh the timeline again, what we see is that the payment service has been redeployed, and what we do see is our environment variable for third-party APIs has been changed to say no. Originally, it said yes. And again, this getting back to that automation gap slide that we were looking at earlier, it's not that someone like another service owner like Rachel doesn't have the technical acumen to perform this type of action where we're going to redeploy this pod with the change of an environment variable. But it's more around that that contextual knowledge, right? That service owner level of knowledge of the fact that that mechanism is available and that it's there for a reason, which is to decouple the dependencies on these external services, serving fairly like a safety net for scenarios like this one. And so ultimately what this does is it empowers others to be able to help Paul tend to his service, right? And again, going back to the fact that as a service owner, Paul might be bombarded with requests and inquiries about the payment service, right? How long is it typically taking people to transact? How many people start to put in their payment information but then leave? Adding all of that into kind of Paul's list of service ownership tasks. If Paul is able to provide these push button mechanisms so that whether it's, again, IT or platform engineering or even marketing or customer support can have these easy buttons to perform these tasks without needing to always rely on Paul, that saves an inordinate amount of time. So really quick, what we'll do is dive right back into Rundeck very briefly, look at how this particular task was accomplished, and then shift towards a Q&A here. So this was for our manual diagnostic data, and what you can see, if we'll go now to the toggling the service dependency on third-party APIs, is that for all of these what we call Rundeck jobs, there is the web portal GUI. As mentioned, these can be triggered by webhook, which is what's happening in this demo from PagerDuty. But what's demonstrated here is that the front end for these very technical tasks are intentionally very simple, meaning we're trying to provide an easy button to end users without making any assumptions about their skill set or knowledge about the underlying infrastructure, tooling, applications. So we're not making any assumptions about whether or not the end user for this job knows about Kubernetes, knows about these third-party APIs. Maybe if we're using another tool to actually perform this task, like maybe we're actually using Ansible or Jenkins because you already have these automation pipelines built out, we're not going to assume that end user knows anything about those underlying automation mechanisms. And so in this case, this job has some inputs, and we can guide the user as to what options are available for these inputs. In this case, this job is purpose-built to be triggered from PagerDuty, so it requests a PagerDuty incident ID, and then a service name, and all of this is extracted from the incoming payload from PagerDuty. When we look at the job definition, it's very much the same as we saw earlier, where we're using a mix of Rundeck's native out-of-the-box integration plugins for Kubernetes, but we're also demonstrating here, right, that we can wrap around. If you already have automation written or documented, this step 4 could very well be an Ansible playbook or a Jenkins pipeline. Or a Python script. So it's a mix. It's a healthy mix of native out-of-the-box integrations and then wrapping around your existing or desired tooling for a particular task. And then so all of this comes together to provide an operational framework for these automation mechanisms and providing a more simpler end user interface, whether it's here again in the web GUI or through a tool like PagerDuty or Jira or ServiceNow, etc. So wrapping up, what this has shown is that with these tools, you'll have a way of molding around the operating model or service ownership model that is prime for your teams and where you're at on again, say a journey to full service ownership if that's your intended goal, but ultimately to unburden those people that tend to get interrupted with day-to-day tasks or tend to get escalated to because of their skill set, their acumen, their particular access, or their contextual knowledge about your particular environment, your infrastructure and applications. And so with that, if you want to see more, if you want to go into a further deeper dive with Rundeck, someone like myself or members of my team are more than happy to show you how you can build Rundeck jobs, how they can be invoked and triggered and scheduled, and how we can tie into all of the tooling and mechanisms that you use today. And with that, I'll thank all of you for attending and happy to take any questions.
Yeah, thanks, Jake. If anyone has any questions, feel free to drop them in the questions tab in the control panel. So I'll just read off a few to get started. So how is Rundeck communicating with infrastructure and services, and how is that communication secured?
Great question. So as it stands today, Rundeck is, first and foremost, you should understand that Rundeck is installed in your environment. And this means that it's not SaaS, so we're not requiring you to poke holes in your firewall for Rundeck to communicate with your infrastructure and tooling. And then how Rundeck communicates with your infrastructure is, for those who may have seen on the left here, we have a nodes tab. This is how Rundeck identifies your inventory. And for all of your inventory, whether that's VMs or containers, Rundeck has the defined mechanisms for how you want Rundeck to communicate with these endpoints. And we provide a number of out-of-the-box mechanisms, such as these nodes we should communicate via SSH, these ones via API, these ones via WinRM, but it's flexible, and so you can actually define how you want Rundeck to communicate. Maybe you want Rundeck to wrap around an agent-based mechanism like AWS's Systems Manager, or use the G-Cloud CLI to communicate with GCP instances. So there's a lot of native mechanisms for doing this out of the box to get up and running quickly, but there's also a lot of flexibility here. And we auto-populate your inventory from a number of sources like your cloud provider or CMDB. Hopefully that answers the question. Great question.
Does Rundeck know which pods to target? Does this work for VMs as well?
Yeah, so on that job that I was just showing around toggling the service dependencies, you saw that there was an input field there for the payment service, and that was then used as a parameter for the job steps. So I think you might have a Python script as step 3 of this job. You can put an input variable there where we would provide the payment service as that input parameter. And yes, that can certainly be for VMs, for maybe for a security zone or security group in AWS. It could be for a database. All of those endpoint parameters can be sent to Rundeck from, again, the human in the GUI, or from a ticketing system or incident management system, as shown today.
What if a company is already using a tool like Ansible for this sort of automation? Does Rundeck work with those sorts of tools?
Yeah. So great question, and we get this one often, right? What is the critical difference between a Rundeck and an Ansible or Terraform or Jenkins? And this is best demonstrated by one of our jobs here. I'll just kind of show a quick definition here. So maybe one of the use cases is provisioning, right? You want to provision a new compute resource, and for many people, they would want to use Terraform or CloudFormation or Azure DevOps or Azure Automation for that task. And so what we find is that those tools are great and that you shouldn't move away from them. But a lot of those tools, again, they make assumptions about the end user's technical acumen or contextual knowledge around how that that tool works and how that tool interfaces with the infrastructure and applications. And so if you're trying to move to this model of equipping others and delegating these tasks to others, you rarely don't want to pass them these tools that are used at the command line or in scripts. And so you can see here this Rundeck job that we have has a few steps, and one of them is executing a Terraform plan, but it's pulling it from source control and then executing it. And then step 4 is actually an Ansible playbook, and that's to patch or update this instance that we've spun up from an image. And so this is how we typically see customers using Rundeck with these other tools, which is to both connect them as part of end-to-end workflows, but then also provide a more simplistic or intuitive end-user interface for those maybe less technical users. Or again, if we're speaking about service owners and platform engineers, we're not going to assume that a developer knows everything there is to know about the underlying platform, the infrastructure layer, and so we don't necessarily want to hand them a Terraform or an Ansible playbook. Hopefully that answers the question.
Does this mean the end of tickets?
Great question. So it doesn't necessarily mean the end of tickets. What we do hope that it changes, though, is the mentality around what tickets are used for. So what we're trying to help people move away from is ticket queues, meaning that if I need to request that a compute instance is provisioned from someone in our tech ops team, that as soon as that ticket is reviewed and approved, that automatically kicks off the automated runbook to actually perform that technical task. And maybe you could build in those validation checks so that it doesn't actually require the human to review that. But what we're trying to get away from is that the technical resource in these scenarios doesn't have to go and perform that repeatable technical task while that requester is waiting on that ticket to be acknowledged and resolved. And so ultimately what we're trying to get away from is ticket queues. But tickets will for the foreseeable future exist as a source of record and a source of input. Right? Tickets are very easy for humans to consume as far as this is what I need. These are the input fields, the input parameters. You might have business logic workflows in terms of what approvals are required and who needs to sign off on it. But what we hope is that we can diminish the queues by basically saying is, as soon as something is signed off, that should go ahead and kick off this automation that means that the technical resources don't have to be interrupted with this unplanned work and can continue focusing on more project-based work.
What would you say to someone who might be concerned that a solution like this might mean they're potentially automating themselves out of a job?
Also a good one. So we rarely hear that's kind of the end result of this. What it tends to do, though, is more load balance the workload across the team rather than and it's moving away from bottlenecks. So a good example of this is one of the prospects and now customers that I worked with a couple of months ago had a situation where any and all requests that had to do with their just Linux systems administration across a fleet of hosts got assigned to the one or two people on their team that were really good at scripting, specifically in Python and Bash. And so what you had was a scenario where these tasks always got funneled to these people. And so that person was a bottleneck and a risk, right? If that person is gone for whatever reason, then these tasks just they take much longer to resolve. And so with Rundeck, what they're able to do is offload that, again, that bottleneck and that queue from that person who has that expertise for that scripting language or for that tooling. And so they're not automating themselves out of the job. What they're doing is shifting that acumen and expertise to others, such that others can actually perform those tasks. But if you stand back and look at this equation, there's still that person who is authoring and modifying these Rundeck jobs, and whoever that person is still extremely valuable to the team, because there's always going to be new automation jobs to be written. Your infrastructure and applications are always evolving, so there's likely going to be modifications that need to be made to these jobs. But what you've done is you've lowered the barrier to entry for others to not only perform these tasks, but help, again, modify or extend these Rundeck jobs, hopefully because they are in these more modular steps, in this more intuitive interface than, say, a long 100-line Python script that helps with deployments or provisioning or patching, for example.